I got a new camera. I've completely rearranged my office. I got a ton of Lixie boards, parts, and the whatnots in. And I am going to start showing you guys what I do for a living building Lixies. What it's like to work from home, what it's like to monotonously build the same thing over and over every day, and how to survive that. So today I'm going to show you me building the first batch of Lixie Revision 3. Revision 3 actually uses black finished wood because of import regulation changes with the old birch supplier. Things to do with like deforestation, stuff like that. Stuff you don't normally think about when the wood comes in. It has to come from a real tree. So if I'm saving trees, that's cool. So I've got black Lixies, and today I'm going to show you what I go through to make them. This is my personal set of Lixies here. I use them for development. They don't actually have any brain in the base. It's always an Arduino or ESP8266 sitting there. So I like the ESP8266 because then I can just OTA update these no matter where they are in the room. And then this might look familiar to like old school Lixie fans. This was the original prototype with the completely cut through digits that just didn't work. Sorry if the focus is weird because I'm still getting used to the DSLR. Over here I've got the soldering station. I've got it on a wood platform. Man, this focus is driving me nuts. I've got it on a wood platform with just a bath towel underneath, and that's just to help give it a little shock absorption so that the pump noise for the hot air and fume extraction doesn't transfer to the floor. I'm in an apartment. There's some, things I have to take care of to make sure I don't have too much noise. This is the computer desk. It's just some crypto there and a photograph backdrop there. These are some finished Lixie boards waiting to go out. And over here, these are the panels from China for Lixies, and there's still quite a bit of those right now. Some extra Lixie lenses. Over here, this just looks like a pile of cardboard, but it's actually tons and tons. It's almost 40 pounds worth of Lixie digits, and then today I got in the new wood with the black Melamine finish, which looks like this, if I can get it to cooperate and focus. So, very sleek looking. It runs into none of the same issues of like peeling and odd knots in the middle of the wood that the birch had. The birch is just super weak. You could squeeze it in your hand and it would break. Melamine, not at all. Super strong. Or I should say melamine finished MDF. MDF is the wood we're using now. And then yeah, just some extra tools around the place. Cables. I haven't finished cable management, especially back here for the reflow controller. It's just dangling. And this is what I call the dirty desk. So this is just all the junk. You just pull it out of here if you need a desk to do dirty stuff on, like glue or, the sort. Printer, shipping supplies are in this corner, a bunch of boxes, the white mailers they go out in, which I am a little low on, but I've got more coming in. And a parts drawer that I will never ever have the discipline to use. So that is the office setup right now. It's just sort of something I'm trying out, just a little more organization and cleanliness to it. Oh, this is an 8-pound ball of nothing but the protective backing paper that comes on the laser cut parts that I've been building since November 2016. So it's about 14 inches wide, it weighs 8 pounds, and actually, okay, this is gonna be kind of a dick move to my neighbors, but I just want to convey how big this ball is. I won't drop it from that high, just. Okay, I think for the rest of this video, focus is gonna be set completely manual. I'm gonna have to start doing that because I've just reviewed the footage that you've just seen and autofocus is just super slow. So let's start by getting the wood out. Okay, so my laser supplier is Pinocchio. When you order through them, they come in, the sheets will come in a cardboard wrap like this. And they have protective backings that I believe are from the suppliers. So this side is open, but on the other side, if I can flip it without it all falling off, on the other side there's an extra adhesive paper that holds all the pieces together in the sheets so they don't all get loose and fly out everywhere. So you could sit there and pull each piece out like this. But again, part of this video is about surviving the monotony of assembling the same thing over and over and over every day. If you go to the back of the sheet, grab a corner, if you can. All my nails are gone right now. Come on, you bastard. There we go. Okay, just grab a corner and see if you can peel it flat like this all the way along. And this, you know, some of them will flip up a little bit, but this saves a lot of time getting those parts out. And then some of them will probably flip at the end here. Yep. But, ton of time saved. Just get it all back on here. Alright. And then these I don't actually add to the big old ball. That's just for the plastic. These just get thrown away. Now comes the super fun, totally not monotonous part of sorting out what I call positives and negatives. So, whenever you do laser cutting, you're left with pieces you don't need. So, I need this part for Lixies, I don't need the part from the middle. So I have a big old box which is full, actually. Let me grab a bigger box. Okay, bigger box. So, totally fun and not at all monotonous part is grabbing all the negatives and throwing them in a box. And what I do is I save them for later for stirring solder paste. Because it's just a free little stirring stick. I use it to stir them up and then wipe solder paste across stencils. So let's just go into time-lapse mode. You know what? I just realized a fault of the freaking Canon DSLRs that I'm filming on is they don't have DC power in. How does it not have DC power in? So I'm relying on just battery right now. I'm going to go ahead and kill the camera for the time being. I'm going to resume recording after I'm done doing this. So no time lapse there. Alright, so those are all separated. Now I've got a big old pile of Lixie tops with the protective paper still on them. Now the next sheet down is the base parts. These guys. So, alright, they're all peeled and separated, but I wanted to take a moment to assure you that I don't have a rat problem. Neither does Pinocchio. This sight will look familiar to anybody who's ever owned rodent pets, but that is just what I call dead ants or droppings, depending on the mood. That is the little screw holes from the Lixie base pieces. Some fall out on their own, some you just pop out while you're building them, but if you're gonna build a Lixie, be mindful that you're gonna have a lot of those. And they get everywhere and they will stab your foot, so be careful with those. Okay, so what you see here are the laser cut components minus the glossy cap. So you've got your digits 65748392001. That took a long time to memorize, but that's the ordering, and then that way, the reason I did that is if I ordered the panes from front to back, 0 to 9, it would count up and then immediately pop back to the front of the stack. But by doing the 65748392001, it actually counts back and forth continuously. It oscillates. So just a little detail, and that's how a lot of Nixie tubes were set up, like the small IN18 tubes. IN18? No, that's the big one. IN14, I think, is the little one. Anyways, this is the filter piece. It just stops light from entering any pane but the one it should from the LED beneath it. And then the top and base. The base holds the screws. Basically, when it's put together, it goes like that. So, I am going to glove up and build this because if you don't wear gloves and you put this together, you're just going to have finger filth throughout the whole thing. So gloves are not an option. And you will have to get used to wearing nitrile gloves for, sometimes an hour or two at a time, and dealing with your hands sweating buckets inside them. Because if you decide to make a product that it's to be expected that it's like, ships like an iPhone, it's pristine, then you have to wear gloves. And then the other thing that I use is a dulled box knife, just an old rickety plastic disposable one. Got 1,000 of these laying around. And then that way it's sharp enough to get at the paper so that you don't have to destroy your fingernails. But it's not sharp enough that if you do it right, it won't hurt the material underneath. So I don't actually peel these filter pieces, or I should say I haven't. But now that I'm using black, I think I'm actually gonna start peeling them to match the black. We're just gonna black the whole thing out. So I may actually just peel the one side of it that would be up, because this is a part you wouldn't normally see anyway, so I haven't bothered to peel them. So here's how it works. I grab my top piece, grab a base piece, put them over each other, and then I start peeling digits. And with the way the Lixie is set up, I can actually dig my knife anywhere down in this corner or up at the top here, and it would be hidden away by the rest of the assembly by the time it's done. Not that I want to intentionally scratch displays, but I always start from those areas for that very reason, so that if they do get a little nick, it's okay. But the digit here is a bit different because it's right on the face, so I just try to drag that paper best I can. There we go, just to get it up. And then we get our backside. All right. And then one thing you would immediately notice if you used acrylic laser cut parts is they are highly statically charged. I have never had a problem with them with electronics. They've never killed anything of mine, but they are so, I think it would be negatively charged that any like stray pieces of paper nearby will just flock to it. And actually, I can take even just my hand near it and the paint will move. So keep that in mind. You gotta have a clean workspace. Or an air compressor for when you're done to blow them out. I have both. Now, with all the digits placed, I can take the filter piece and just pop them in. This part's quite satisfying. And then pull the base up. It's just gripping the sides, not the actual front of the panes. All right. Very cool. So that's the top of it assembled. So it does have a fair amount of paper junk stuck in there from peeling. There's just statically stuck. It's not actually adhered. So either an air compressor or a compressed air can just shot down the side would fix that right up. All right, time to make a board. So when I get Lixies in, I do enough volume that I panelize and order tons and tons and tons of panels. So they come in a sixer like this, and then they are routed top and bottom of the board, but V-scored down the sides. So you can just break them out of the panel, but I'm not gonna do that right now because I've got a few spares laying around. I'm just building the one for the video. So once the board is out, the majority of it is surface mount. So there's 20 surface mount LEDs right here, and then 2 through-hole headers. And a change with revision 3 is that I'm gonna stop adding a capacitor to every board. It's just kind of overkill. So I'm gonna include 2 capacitors in every, shipment that someone buys, so that they can put it anywhere before the Lixies in the circuit. That's all you need. You don't actually need one on every Lixie. So what I need to do first is grab my solder paste stencil and the jig for spreading it and get some new gloves on. This butt ugly piece of shit is my soldering paste jig. I've used this for 18 months of building Lixies and never cleaned it, just so long as this center part is clear or whatever's caked into it is caked into it enough that it doesn't come off. So I'm gonna build a new one soon, but it still works just fine for me. So I'll put my board in the middle here and then take a soldering paste stencil. Now, if you are assembling any product with surface mount stuff with more than like one part, get a solder paste stencil, because otherwise, this is just so I can swipe solder paste, drop 20 LEDs on it, throw it in the oven, and I'm done. Without solder paste and a stencil, I would be sitting there with tweezers, holding an LED in, bringing my iron over to every little leg, applying flux, and fixing each LED in, and probably melting some of the plastic when I do so, because I'm not really good at surface mount soldering with an iron. But paste soldering is so much easier. So we get this put in, and we get it lined up with our parts of our board. Okay. We get it lined up so that all the contacts are right underneath all the holes of the stencil. I then take some tape. And there's a million videos online about surface mount soldering with a stencil or reflow soldering with an oven. So I'm not going to go into a whole lot of those details here, but it's the method I use and the method I feel if anybody is doing like even a medium run of a product themselves, you have to do stencil soldering. Okay, so that's all lined up. Now I gotta get my paste. My paste has warmed up to room temperature, You're gonna wanna keep it cool, it just helps it last longer. And from before, those negatives I mentioned, I actually forgot one in here. The little extra piece you get from laser cutting those bases, that's what I use them for, is a little stirring stick. So let me throw this old one away. Just the inside of that base piece from the laser cut works as a great little spreader on these. So I take my solder paste, gather up a little chunk of it, and then just, the way that I do it is I completely cover the board, or all of the contacts I should say, completely cover all the contacts like this. And then, after I've done that, then I'll take it and swipe it across. And then sometimes, just to be sure, you can actually add it back over all the contacts and then lift your jig off, because that will lead to just a little bit more solder on all those pads. Let me find my tweezers one moment. And then I just use tweezers to grab this out. And that's a pasted board. So normally I would do a run of, several dozen of those at a time, but then I just put another board in, take my spreader and just gather up all that paste and put it back in my jar. Then you have a second pasted board, but I don't need a second pasted board right now. So I'll actually just take the same spreader, the clean side of it, and just wick away that extra solder paste for the time being. We'll save that one for later. And now you've got a filthy stencil, and I found my favorite way to clean it. Whoops. Is by putting it into isopropyl alcohol, because that will help dissolve the solder paste. So I will go put this in alcohol. Another thing you can do for cleaning stencils and tools is, instead of dropping those stencils into alcohol, you can put them in deionized water in an ultrasonic cleaner. You can get them on Amazon for about 20 bucks, and they'll have a tank about this big, and then what it does is it shakes the liquid at an ultrasonic frequency, which helps break up any bonds of adhesives and things like that. So anyways, let me get set up to put the LEDs on. I take duct tape, wrap it around like this, press it kind of flat to the table there, and then grab some LEDs, and then I place the LEDs on the tape here. Now, they're still in their part reel from the factory, and cut into increments of 20 is how I keep them. Hold on, I'm going to turn off my ultrasonic cleaner. Stop it. Stop. And then place the LEDs on the tape. Now they're still in their plastic tray that comes from the reel, that comes from the factory, and they're cut into 20 quantity. So that way I can just grab one of these for a board, slap it down on the tape, grab the board, put it down on the tape, and I'm safe for gloves now. I'm done dealing with paste. So I then fire up the pump here. Now I can just grab the pick and place tool. The board and the LEDs are oriented the same way, and I can just grab them and plop them down like this. And basically just be a human pick and place machine. Now later in the year I'm looking to move towards factory assembly so that I don't have to do this part anymore, but it's really not that bad if you're set up with the right ergonomics and the right tools to do it. This pick and place tool I'm using is actually part of a soldering station that I got on eBay for about 200 bucks. It's called the Xtronic 4-in-1. And it's got an iron, fume extractor, hot air iron, and a little pick and place tool. It's very, very handy. Alright, then that board's placed. So now, since I'm only doing the one, we get the oven ready. Cool thing with reflow soldering is that the surface tension will actually straighten the parts out for you a little bit, but you want to give it the best shot you can, just to make sure that it comes out pretty. Just gotta straighten that one up. Alright, so up here on the desk is a modified toaster oven, which is just a staple of any electronics geek's workshop. So just everyday from the store toaster oven, dedicated to making boards. Don't ever put food in this again once you put leaded solder or even unleaded solder in it, because the flux contamination will give you cancer, and that's bad. So you have to get one that's has like a stay on feature that'll just leave it on indefinitely. You don't want to use the timer. So get one with the stay on, and then preferably top and bottom infrared heaters. So what we do is we grab our board, drop it in there, just keep it fairly centered, and then what I've rigged up around back here is an Arduino controlling timing and temperature. So just gotta start that. And then you might be able to hear, it's beeping, it's gonna start cooking. Alright, so as this heats up, you're gonna see the solder paste under the pads. I'm gonna do a little digital zoom, because that's about as close as I can get with the lens I've got. You're gonna see them liquefy and wick themselves up the legs of the LEDs. And they're gonna happen probably back to front on this board. Alright, should be going off in just a sec. Alright, one's in the back starting to liquefy. One's in the front. Slowly going by. And that's what it looks like. Now all of those, and the timer just went off, all of those are soldered at once. So you can imagine how much time that saves versus actually having an iron and doing it manually, because 20 LEDs with 4 legs each, that would be a total of 80 joints you'd have to solder per Lixie board. And I do several hundred Lixie boards, you know, every month or two. So big time saver there. And then when this is done, it's quite hot, so I take tweezers, pull out the tray, and then let it, you know, slowly cool down. And I don't do that right away because you don't want to give thermal shock to your board. So let it sit in there for a little bit, let it slowly start to come down, and then open the door and pull the tray out. So while I'm waiting for that board to cool down, I'm going to talk a bit about this cool little test jig that I made. It is literally just a bunch of wires soldered to joints to an Arduino. I know it would have been so much more elegant to get a board made that just has like an ATmega or ATtiny on it, but made do with what I had. And it's got a little OLED screen on the front for status. So I've got 4 boards here, and we're going to test each one of them to see what the fault is. And on this one, I believe this one has color faults. So when I get this plugged in here, it's going to start testing. That one is actually a data continuity error, because this LED down here, this is actually an intentionally destroyed LED for testing this jig. But data does not pass from this one through this one out the other side, because the Arduino is actually sending the frames for LEDs in the one end and watching on the other end for the data to pass through. and it didn't make it through on this board. So now I've got a little warning that says fail, data continuity and blue LEDs. This one, oh, there it is. This one actually is missing continuity between 5 volts from one end to the other. So when I get it plugged in, it should tell me that on the screen. And I've got some LED issues on that board, but main thing is it failed VCC continuity. So there's that. This one, actually I think this is the one with the color issues. So it has continuity from edge to edge on every connector. It can successfully pass data frames to the next Lixie, but it has dead sub-LEDs inside the RGB LEDs. So when I run this, it's not going to hit any issues at first, but it's going to cycle through red, green, and blue, and then go burnt and tell me that LEDs 1, 13, and 18 are all having issues. And that's because over here on 1, it's cyan because the red LED died. This one is green because the red and blue died. And this one is magenta because I can't think right now, because the green one is dead. And it can actually tell me on the screen which LEDs have those issues. And that's because when it was swiping through red, green, and blue, one LED at a time, the other end of the power connection is actually tied to an analog pin on the Arduino. And it's watching the voltage drop from one side to the other, one LED at a time, one color at a time. So there's an expected voltage drop for red, green, and blue, and if it doesn't meet those standards, then it can detect which ones might be broken. So that's pretty cool. And finally, this last board, I'm actually not sure at all what's wrong with it. Let's see. Oh, that's a good board. So now, I got the little rainbow congratulations. And this part is for when you're actually putting the fully assembled Lixies on, it starts running the numbers. So we'll come back to that. That's a good board. I'm not sure why that was in the dead pile. I'm gonna keep testing that, but yeah, that's the tester. And now our other board should be cooled down. Should be cooled down, but just to be safe, we grab it with the tweezers again. And then now, we put the headers on. All right, jig number 2 is literally just a breadboard with some marker in the spots that these headers need to go. So I pop the headers in, drop the board on, and then I'm ready to solder it. So let's get the iron warmed up. Another cool thing about this Xtronic iron is it's got a built-in fume extractor pipe right here. It can get a little annoying if you're trying to get into small spaces, but you can just undo a screw and it comes off and gets out of your way. But as an example, let me see if I can get my black shirt in front of it so you can see the fumes. When I add solder to this, nothing's coming off of that. It's just sitting there boiling on the tip. But with the pump off, this is what you would normally get, and anybody who's ever soldered without fume extraction is used to this. You just get a ton of that nasty, cancerous shit. So either get yourself an iron like this, or get like a full-size fume extractor. They're like 40 bucks. They're totally worth it. So now that the board's in the jig, we just do the through-hole stuff. And that's done. Now I got the headers on, and the breadboard helps keep them nice and straight and safe. So let's go back to the jig, and I'll test this new board. Let's drop our brand new board on and hope that it works. Should work. So again, just testing through red, green, and blue, continuity, and we're good. This board passes all tests. Now we just add it to the Lixie display and we're almost done. Oh my god, we're back again. I just had to charge the camera because Canon DSLR cameras don't have a DC in jack. The fuck, Canon? Also, you can't get 4K video unless you spend, I think, a minimum closer to $2,000. I mean, $500 smartphone does 4K. I know it's not the same sensor, but come on, Canon. Take our board, line it up at the bottom there. And then this is where a little bit of dexterity comes in, depending on how tight the laser cut parts were. Actually fitting the screw up, holding it in place with no hands, and then getting the nut on. Sometimes that's a pain in the butt, but so far this MDF has been so strong feeling that I don't think I'll have any issues down the road with that. Sometime this year I will be releasing a sequel model to the Lixie, a Lixie 2 of sorts. These tiny, tiny nuts will not be part of it. I won't have it. But yeah, sometime this year I will be releasing an updated model. There's a couple features I'm hoping for, like interchangeable panes, because as of the current design they are glued in the top. But I think sort of like a click in, click out thing. It's going to work really well. I've got a bunch of prototypes, but all of which have failed on one thing or another so far. So that's not happening anytime soon. But for now, sexy black Lixies are what's in. All right, sweet. Now it's time to fire up the glue gun and get the final piece on top. Okay, so the way these are glued is they used to be glued in two big globs on the top of the plastic piece, but that actually caused a bit of warping if it got too hot. So now I start by gluing in the corners here and then placing the piece on top. So we'll see how this goes with the thicker top. Alright, act quickly here. Just making sure it's on super straight. No obvious seams or anything. Alright. Got the top glued. So let's throw this on the jig again real quick, just to make sure nothing happened to that board in the assembly process. So drop that in. It's going to go through its tests. Red, green, blue, done. Alright, just a little smudge on the one in the back there, but that's looking pretty damn good. I love the black Lixie! Woohoo! That is awesome looking. And just for show, let's go ahead and peel off that top. Get it completely black. Come on. There we go. Ooh. Wow. That looks awesome. Woohoo! It's just got a little bit of paper gunk I've got to spray out of there, but Alright, with a little bit of patience and a lot of time, that is how I make Lixies.